Substitution reactions occur in chemistry when we see a leaving group exit a molecule in place of another molecule. And what I'm going to do in this video is walk through how we can look at these two species and then determine with a high degree of certainty what the products will be. And to do that, we're going to be needing to identify the leaving group, the nucleophile, and the electrophile. And so, based on the molecule that we see to the left, what we should intuitively see is a difference in electronegativity between carbon and chlorine. We know that chlorine is a lot higher and to the right of the periodic table. It's got more protons, so it's going to be pulling on those electrons harder than carbon is. And because of that, we would expect the chlorine to have a partial negative charge. And the consequence of this partial negative charge is, more importantly, going to be the existence of a partial positive charge on the carbon directly next to it. And if I were to dissolve some potassium methoxide into solution, what we would expect is to get some potassium ions, K+, and some methoxide ions. They're going to look like this. And so the thing is, if we were to now identify what a nucleophile is going to be, a nucleophile is going to be something that's going to have a lot of electrons around it, and it's going to want to attack an electrophile. Electrophiles are going to want electrons because they're going to have a partial positive charge. So if you're partially positive, you're going to naturally attract negative things, which are electrons. So in this case, our electrophile is going to be this carbon. I'll just label it E. And our nucleophile will be this methoxide ion. Okay, and so what's going to happen is the nucleophile will attack the electrophile. The lone pair of electrons from the methoxide ion will form a bond to this carbon that is directly next to the chlorine because it has a partially positive charge. And when this happens, these electrons that previously existed between carbon and chlorine are going to break and go with the chlorine to form a chloride ion. And so the products that we get after this reaction occurs is this carbon now still has the same protons it had before, but in addition to that, it will have this methoxy group, this functional group attached to it. And what will also happen is, because we're in aqueous solution, the chloride ion will have 8 valence electrons and a negative formal charge. We would expect to find water molecules solvating this very nicely because, as we recall, we're going to have partial positives on these protons within these water molecules, so we're going to be forming a lot of bonds, intermolecular attractions between these chloride ions, and the same will also go for the potassium ions that exist. And so this is going to be a brief introduction to what we see with substitution reactions. A key point to take home also is the fact that one of the reasons that these reactions will exist in the first place, and one of the reasons you're going to see these reactions occur, is because these leaving groups are very stable. Okay, so just remember that a substitution reaction is very likely to occur if the leaving group is going to be very stable on its own. If you think of very strong acids like hydrochloric acid, HCl, one of the reasons it's so strong is because the conjugate base, the chloride ion by itself, is so stable. So Cl is an excellent leaving group for a molecule. That's one of the reasons why you see so many halides as leaving groups in your substitution reactions in an organic chemistry class. So I hope you guys find it useful, and thanks for watching.